Hello, everyone. My name is Eric Matson. I'm faculty at Comp Bio and Fred Hutch, and I've got some folks from my group here, and we're going to do a bit of an onboarding, just introducing the awesome computational resources that we have at Fred Hutch. So, folks, do you want to say, I guess, Mary, Maggie, Jared, Zorin, and Hassan, do you want to say hi to everyone?
Sure. Hi, I'm Maggie. I'm a grad student in the MCB program.
Hi, I'm Jared. I am a master's student at the University of Oregon Bioinformatics and Genomics program.
Hey, I'm Zorian, and I'm a PhD student in the Genome Sciences program.
I'm Hassan, and I'm a PhD student in the statistics program.
Great. So this is our agenda today. Welcome. Thank you for being part of my group and for participating today. I guess I can just also say, like, the system that Scicomp has put together is awesome. It's a good playground for being able to get stuff done. So I'm just going to give a demo of that. And with that in mind, be nice to your sysadmins. If you file support tickets, be kind. So here's just really briefly, I'm really just going to focus on command line tools that are sort of special to the Fred Hutch. I'm not going to cover GUI tools. So there's this thing called motuz. I'm going to be talking about economy file storage and moving stuff around. Fred Hutch has this new thing called, I don't even know how to pronounce it, motuz. I've never used it. It's supposed to be very nice. It allows you to move stuff around easily. Also, you can apparently log in with X, like have a graphical user interface when you're logging into the interactive systems. That sounds cool. I guess I don't use it. And if you are looking for that, you can look at look at our biomedical data science wiki. I'll be talking more about this in a second, but I'm sure there's ways, there's documentation there about that. I'm not going to be talking about workflow management systems. That's like a huge topic and super important, but I'm not going to talk about it. So Nextflow is basically the tool of choice for Fred Hutch these days, but I know people get a lot of value out of other tools like snakemake and make. I'm also not going to talk about Docker and Singularity. I guess I'll just say one thing, which is Docker as such is not supported on the Fred Hutch servers, at least 99% of them, for the simple reason that Docker is not very secure. It doesn't have a good security model. So they do have this alternative thing called Singularity that provides a lot of the value that Docker does give, but it's not exactly the same thing. But you can take Docker images, Docker files, and things like that, convert them over to Singularity images, which is the recommended way of doing things. So any questions there, folks? Okay. So there are lots of resources available. The SciWiki, which I've just shown, is just amazing. There's lots of different things that you can look at, and I'll be referring to it a little bit during our talk. It's public. You can get credit for your contributions, which is awesome. So please do contribute. There's also the Coop, which I've linked to here. And this is also, these links are also in the YouTube description, so you don't have to type them in. The Coop has all sorts of resources for learning, in particular fredhutch.io, which is offers classes and instructional in computer stuff at Fred Hutch. And also there's a very active Slack channel that's under this, fhbig.slack.com, which is apparently very active. I think, Jared, you've at least played or talk to that folks, right?
Yeah, the Coop has been extremely helpful.
Awesome.
Sam is on there every Thursday answering questions about Nextflow, and there's multiple channels that are, super helpful in all different facets of the computing world.
Great. Okay. So this is the sort of stuff, the Preflight setup that you should have set up as part of your sort of onboarding to being a citizen of the Fred Hutch. So when I say group setup, so here I am. I'm going to hop over to Rhino, which is one. I'll talk about that in a second. But So when I type groups, there's all sorts of stuff. I'm involved with lots of different collaborations, but you should have something that says like something about the group that you work in, because that's going to be important for like what the, all the files and things like that. So when I say groups, I mean like a Linux group set. So if you type groups, you should recognize something that is relevant for you. And if not, then you should contact your sysadmin. Cluster access granted, that should be automatic, but if for some reason you get some error message when we try to submit something to the cluster, no big deal, just email Scicomp and they'll fix it. SSH keys are uploaded. This is just to make things really easy so you don't have to be typing your password all the time. So I'll just assume that you have done something to generate a key. So here's my public key, and this is how I always do it. I always copy it using SCP up to Rhino. You can use whatever motuz or whatever else you want to use, I guess. And so this is going to copy my key, which I've called penguin.pub because that's what my computer is named in the .ssh. So maybe I should just talk a little bit about the syntax. So this is the computer name. So I'm going to be using Rhino here, and then there's a colon, and this is the path on Rhino that I want it to go to. So I've copied it, and now I can go to Rhino and say cat penguin.pub and then append that to authorized keys. So I'm not going to do that now, but because it's already there. But that's what I would do. That's what I always do. It's just 2 steps. And you will have to type in your password twice, but whatever. Cool. So that's sort of just the Preflight setup. Any questions there? Okay, great. Great. So let's talk about interactive compute. So I've been on the Rhinos. The Rhinos are pretty beefy servers, 36 pretty strong cores on each of them, and there's lots of them. So when you do SSH Rhino, you will get randomly assigned, not randomly, you'll get assigned to the Rhino that has the least work on it. So you don't have to say Rhino 2 or Rhino 3 or something. You could just say SSH Rhino, and it'll connect you to whatever one is sort of most available. So they are for non-intensive interactive use, and there's this thing called Arbiter. That if you do something too computationally expensive, then Arbiter will email you and basically throttle your account, and it's going to be like this. So I have a kid now, and like you will get sent to the uncooperative chair basically, and your resources will be sort of limited for a little while there. Don't use Rhino for hardcore compute. If you want to do interactive hardcore compute, you do this thing called grabnode. So that's just, you just write grabnode. Oh, okay. Okay, one moment, please. Hold on, I need to, yeah, my password's long as it's supposed to be. Hold on, I will get it here. Because of all this key stuff, I don't actually log in, type my password that much. Doop-a-doo. Nothing to see here. Okay, there we go. All right, so now I can grab node. How many cores would I like? I'm going to make this fast, so I'm going to not request a very fancy node. So I just want 1 core. I just want 1 gig of memory, and I just want it for a day. And I don't need a GPU. So hopefully this won't take too long. Yeah, here we are. So now I have a wee compute node that I can run hard processes on. So let's see. If I want to see what else is going on, Okay, there is somebody else on this. I'm not, just to preserve their privacy, I'm not actually showing them, but you can see this other person is running some stuff on this. So this is not exclusively my own, which is not surprising because, oops, wait a minute. Am I showing the wrong thing? Nope, that's right. Okay. Which is not surprising because I only asked for 1 core. If I had asked for more, for 4 cores, if I was assigned to a 4-core machine, then I would have that machine all to myself. So that is grabnode. And so if your group, like, so we own a couple of our own interactive servers. So those limits that I talked about are not applied for that case. But if you don't have one, using grabnode is a great way to sort of get your own machine for a little while. But please, when you're done with grabbing your node, just log out of it. You can just do exit or Control-D. And then, so I've relinquished that and somebody else can then use that node. You certainly don't want to like grab a node and keep it for longer than you actually need. Make sense? Great. Okay, that was grabnode. So just some fun things, I think. So there's this thing. So if you're ever on the cluster or something and you want to know who somebody is, you can just finger them. And so this, because this has some IP addresses, I'm just going to say head into. So this shows who I am, what my name is, what my shell is, and my home directory and things like that. So if you're curious, if you're annoyed with how somebody's using the cluster, you can find their name out and you can send them an email, a very gentle email. And just for extra fun, there's this thing called write, which like back in the old days, you would use to communicate with other people that you're on the same mainframe with. So I'm just going to write myself. And so then I can just write messages like, why are you abusing the cluster? And it will sort of put that in their prompt. So that's a little bit of old schoolness that still persists in these modern things. So you can write anyone and it'll show up in their terminal. Cool. Oh.
I have a question. So if they're not logged in, will that message just appear as soon as they log in?
I think it will. But of course, they're using something awesome like, if they're not logged in, I don't think it'll do anything. But of course, they're using something like Screen or Tmux, like a sane human being, and then it should show up.
Gotcha. Well, we should just get rid of Slack at this point.
So let's see. I'll try to remember to do FC a little bit later. But that's another, I think, very fun thing. So, okay, so your home directory. So if I do CD, that takes me to home Matson, which is my home directory. And this sounds, okay, well, that's what it should do. But it's amazing. So this home directory is shared across all the different compute resources. If I'm on Rhino, it's there. If I grab a node, it's there. If I'm on the cluster, it's effectively there. It's easy to write to my home directory. And so that we sort of just have this one place where you get to keep all your stuff. So that's pretty cool. It's 100 gigs, which is not nothing. But if you want to use more, there are lots of other resources for storage. Let's see. So there's one, people probably know this, but there's one extra cool thing that I don't think everybody does know about, which is .snapshot. So as everybody knows, in Linux, if you delete something, it's gone. There's no recycle bin, but there is. It's called snapshot. So here we are. I've removed this file called toDelete. And I'm like, that had all my important results in it. So what I do is I do cp dot, so this is in my home directory, snapshot And I start tabbing, and what is this? There's all sorts of stuff. There's, so why don't I just ls that? Oh, that wasn't very helpful. So there are daily backups and hourly backups and weekly backups and monthly backups. So I can just go ahead and CP from snapshot hourly. And so let's take it. I actually just made that file sort of recently. So let's take it from, yeah, at like 1 in the morning. So let's see, where am I? Teaching. FH compute environment to delete. Boom, now it's back. So I was able to just get that back from the snapshot. I should be clear and say actually to delete is completely empty. So I did that. That was just a demonstration. Okay, so that's sort of your home directory and snapshot. Any questions about that? So the snapshots, those directories are sort of named. It's a rolling thing. Like you can see, it only keeps a couple weekly ones, one monthly one. I guess they figure if you deleted something more than a month ago, then well, it's too bad for you. Cool. What's next? Okay, so software. So by default, there's like not a lot installed. I mean, whatever. There's the Unix basics. So, for instance, there's not SAMtools. So SAMtools is a pretty popular thing that you might expect to have available. And it is, you just have to load the SAMtools module. So there's this ML SAMtools. And actually, the head of Fred Hutch Scicomp told me to remind people that there's this thing, Control R, which I covered in one of my previous videos, but I do Control R and then I type in things. So here I'm doing ML, and that takes me back to the most recently executed thing that had ML in it. And I can keep on doing that. You can see I misspelled SAMtools here in my history, but you can keep on doing that to cycle back through your history. So now I have ML SAMtools, and SAMtools is now available. Woohoo! That's great. Yeah, so there's lots of modules. I learned recently that there's sort of a secret one called fhDev. So like auto tools and things like that, that you sometimes need to compile software is not available. But it is available if you do ML fhDev, and now I have all the auto tools and sort of development stuff that you might want to have. And there's like a whole list of these things available. It's scientific software. So if you're curious about what scientific software is available, there's just a whole list of things, and they are super prompt at getting things installed as a module if you want them. So if there's something here that you think is a reasonable ask for them to do, they'll do it. Whoa, I can't believe they have this. Anyway, that must be a dependency of something else. Cool. Any questions about that? Okay. So storage. So in addition to your home directory, there's fhfast. So fhfast is associated with whatever group you're in. So I'm in the Matson E group, and so I have access to fhfast Matson E. So this is where you want to put stuff if A, it's sort of too big to put in your home directory, or B, you want to share it with other people in your group. So in my group, it's not super well organized, to be perfectly honest, but everybody has their own group, their own sort of directory. If anybody can make a directory here. We also have some shared projects. And so these, if we have a specific project with lots of people contributing and there's not sort of one owner, then it goes in here. So that's sort of a handy thing. So fhfast is a normal POSIX file system. So so for instance, we you have all these permissions and things, all the sorts of things you would expect with the usual file system. And so if I do, this is actually, it's just a shortcut for ls-l, and this is showing the owner, their group membership, the group ownership of the file and its permissions, and its size and whatnot. So that's fhfast. It's a good, solid POSIX file system, but it can be expensive for people who have lots and lots of data. And so for that, there's economy file, which I'll cover next. So economy file is a bit of an interesting thing. So it's not a normal file system. It's an object store. So that means that there's some protocol for uploading stuff to economy file system, and there's a protocol for getting things down. But you can't use it for sort of interactive use. So if people are familiar with S3, this Amazon Web Services thing, it's sort of, you can think of it as more equivalent to that. And actually what I'm showing you now is sort of legacy economy file. Nowadays, they are actually having people use S3, but the idea is pretty much the same. And so I'm just going to demo the legacy thing. Which I think we will continue to use in perpetuity, just because we're grandfathered into that system. Maybe not in perpetuity. That's sort of a long time. Let's see, is SW2. Yeah. Okay. So the first step to do is to say this. I thought I was supposed to have V2 like that. Anyway, you do some sort of SW2 account thing, and that basically logs you in. And then there's this SWC command, and there's SWC ls, for instance, which lists a directory. So when I say it's not like an interactive file system, that's what I mean. If you want to ls, that's how long it takes. So there are these subdirectories, individual archive, metadata archive, and so on and so forth. And so now that we've looked at this root, so then we can look at other things. So there was a directory basically called raw data, and so I can SWC ls and get all the things that are in our raw data. And this is basically what I would expect to be in anyone's economy file store. It's just a bunch of TGZ files, because you want to zip it up, send it over there, and then get it back at some point in the future. So these are data sets that we sort of don't need active access to. I can also upload things with SWC upload. And so I've uploaded that to our individual archive, which is something I asked everyone to do as they finished their time in the group. They upload sort of like an archive of all the stuff that they've done. And so you can see here I'm uploading an empty file. It still takes a little while, but it gets there. And then I can also remove that with SWC RM. So that's the process for basically getting things up onto economy file and bring them down. Internally, we have a bit of a script that double checks and makes sure that everything got uploaded by doing a re-download. And that's documented on our wiki, but whatever. You can just upload, re-download, And then, oh, I guess I didn't describe download, or is it download SWC? Let's see. Yeah, SWC download is what you use to get something down, and you just give it the thing and tell it where you want it to go. So cool. So that's economy file system. So that's a lot cheaper. I don't know what the numbers are, but it's very cheap, and there's a pretty generous maximum, at least for people like us that don't have a ton of data. But it's not interactive. Good? All right. Well, we needed, so I said I would do something. I would talk about FC later. So FC is amazing. So if you ever find yourself sort of like being annoyed by the fact that you have to like click through lots of different things, like you have to like do a lot of work to edit something on the command line, you can use FC. So let's say I did that, and then I was like, it wasn't really what I wanted, and I can't be bothered to click all the way back to history. So then you can just do FC, and that drops you into whatever your editor is, and you can edit it directly. So that I'm like, I didn't want FC, I wanted Python. Then I can save that in my editor, and then there we go. I've got my history grep through Python instead. Woohoo! I guess I should also say, just for fun, that like at least on my keyboard, if I hit Control, that allows me to click through by word rather than by clicking through by individual character. And you can go to the beginning with Control A, and Control K kills things. Just random tips. Okay, that was storage. I think we've gone through all these things. Oh, Scratch. Okay. So sometimes it's handy to just have something around for a little while. So for instance, there's this thing, fhScratch delete 30, and this says like Fred Hutch reserves the right to delete anything that's older than 30 days in this thing. So you shouldn't put things here that you want to save a long time, but if you want to just have a bit of a scratch folder, you can. And this is just like, this is just a regular POSIX system. I can remove things. I can copy things to it. It's just good old regular file system. There's also, so sometimes it's really nice if you are doing something very IO intensive that you don't want to hit the, you don't want to work with what this thing is, this magic shared file system that is a network file system. And you want something that's actually, you have your processor and then you have a hard disk that's directly connected to it. Does that make sense? So just for really IO intensive tasks. And that that's under -loc. And this is under a bit of shift now. There used to be this thing called no backup, but they're going to get rid of that and instead do this thing called loc scratch delete 30 and so on. So that's sort of coming up. But if you're interested in local storage, then that's where it will live. So yeah, I mean, I guess I should say like the file system is pretty fast, but if you, for instance, well, So for instance, the Bloom Lab like has this master Git repository where they have everything, all of their projects in it, which is totally cool. Lots and lots of notebooks. But if you get in there and type git status, it's going to take a long time because the network file system isn't very fast. It's sort of cycling through all the different files and sort of going through all of them. So that is one of the shortcomings of a network file system. It does have awesomeness, but it has limitations as well. Throughput is reasonable, but like the latency can be a little bit higher than you're used to. Okay. No questions? Okay, hopefully there will be it for the cluster. I'll try to make it really confusing. So I have just some scripts here that will show us how to use the cluster. So the first thing to say about the cluster is the cluster uses Slurm. You might have been at a previous institution that used something else, but Slurm is what's used here, and it's the queuing system. I was sort of grouchy about this for a while, but actually it's sort of turning out to be like quite a good choice that they made. So here are the basic commands that I use for interacting with the cluster. sbatch, which submits a job, scancel, which cancels a job. I do that sometimes. squeue, which sort of tells me what are the jobs that I've queued up. This thing we'll talk about, and then saccount. So let's just go through each of these things. So I have a wee script here. So maybe we'll just bring that up. Okay, so this is a normal bash script, but it has these extra things. So we'll get to those extra things in a little bit. But this is something I suggest everybody always put in all of their shell scripts, set EU and set pipefail. So EU sort of says fail if anything fails as part of your script. And if you have a pipe where one part fails, fail. So this script is just going to write the host name. It's going to write some text to job output.text. And then also so this is sort of a relative location. And this is like a fully specified path in my home directory. So I'll execute this locally, like, oops. Okay, so it said, one of the part of the script was host name, and it echoed the host name to my file. So let's just see what it looks like to execute this on sbatch. And it submitted a job. So let's see if I'm quick. Okay, well, it's already finished. We'll see, we'll look at this as one that's slower later. So what did it spit out? It spit out some output files that are here. And this thing job output.txt. So now I think it's a good time to go back and look at this little script. So these sbatch things are basically directives that are given to sbatch. So you could specify these flags on the command line, but I like to have everything all wrapped up in one script so that I don't have to write those command line flags every time. So this is saying the number of CPUs per task is set to 1. So CPUs here, remember, that means cores. So this is saying I'm only requesting 1 core for this. So Slurm doesn't distinguish between cores and CPUs. I only want 1 node, and this is where I want the output to go. I want the output to go to job, and then this %j is the job number. I want the out to go to .out, and the error to go to .error. I want to be mailed about all events that happen, and this is where I want the email to go. So let's see. Hopefully, I don't have anything too private in my email, because I was going to bring it up and just show you that it emails. Okay. Let's see. So here is said that my Slurm job with this ID ended, and it also gave me something that said my Slurm job began. So you may or may not want lots and lots of emails. You can always set them up to get filtered by your email program, so they go to a special folder and you can delete them all. I personally find it nice. Maybe I just get lonely sometimes and I want Slurm to email me. But you can also say, like, instead of all, you can say, I just want to get mailed when it fails or something like that. I don't remember exactly what the flags are, but you can look it up in the documentation. This stuff is sort of, I just wanted to put it in here to just show that you can format and you can say where exactly you want the various things to go. You can have those output files go somewhere else, but they're not actually needed. So let's just rm job. As long as you're happy with stuff going where you're executing sq. Oops. What was it? sbatch. Yeah, so you can see that I didn't specify anything, and so it just got spat out to slurm.out. So that was the output. So it got executed on gizmo E1. Gizmo. So, and yeah, so you can look up the characteristics of the various gizmos, like the gizmo nodes on the wiki. So they're different. Yeah, why don't we just for fun, let's just see what happens. Yeah, instead of host name, well, we can say host name, we say cat proc CPU info. Oh, actually, well, it was a point I wanted to make about that. So I'll submit this and then we can look at that. So the point I wanted to make here is that that if you don't give a fully specified path, it's just going to go to where you submit it, where you called sbatch. And if you do give a fully specified path, it'll go there. So just to make sure that that's clear, we can cat subdirectory more output.txt, and that was the output that we gave as part of our thing here. So that's sbatch. Some people like srun. I don't really know why. So srun basically, instead of submitting it and then you forget about it, srun sort of treats it, so it establishes a connection with the cluster node and it spits out all of the stuff that is happening. If you sort of say print something, then it's going to barf it to your command line. But just for the sake of completeness, I will srun this. Oh, let's see. I guess I need to chmod. Oops. So now I can srun it, and okay, it barfs all over my command line. But if you want your cluster job to be blocking and not let you do anything else in your terminal and barf all over your command line, then that's great. You're set. You can use srun. I'm sure there's really good reasons to use it. Don't let me belittle you.
I was going to say, isn't grabnode kind of just a bulkier srun?
I guess you can. I guess maybe grabnode is sort of srun terminal, srun bash, so you can sort of start interacting with it. I'm sure it's fancier than that under the hood. But anyway, we catted proc CPU info, so we can see that we're on a 15 core or a 16 core machine, and that machine is named Gizmo E1. So anyway, that's that. Let's see. Any questions about what we have so far in our little script? We'll go to a slower script later. No? All right. So I don't know. I just thought I would throw this up here. This is sort of, So when I was doing a lot of TensorFlow, I was running a script that looked like this more, where I had an idea of what type of machine I wanted to get run on. So I wanted exclusive access to, because like TensorFlow is a little out of control. Like if you're running it on a machine that has 18 cores, it's going to take over every one of those 18 cores. So you're not being a very good cluster citizen if you don't do something like this, if you don't ask for exclusive access to the node. So here I was saying, I want exclusive access to the node. I want at least 18 CPUs or 18 cores. And so this exclusive just means that anybody else, you're excluded from using this. I want to wait until I can have my own cluster node all to myself. And I'm going to submit to this large node queue. So that's an example of a slightly bigger script. So let's look at something that's a little slower. So here's an example of a slow script. All this does is I should always be having. So all it does is it counts up to 100, and it echoes that number, and then it sleeps for 1 second. So if we do this, here we go. It is not a very exciting script, but it allows me to make a point, which is that if we sbatch slow, okay, it got submitted. So we can see it's here. It's getting run on Gizmo E1, and we can see it's running. The point I wanted to make is that if you're interested in how is the script coming along, you can say tail f, and we can just sort of watch. It's not, in a sense, perfect. It's not always giving me all the, it's not giving me every single number, but it's, it's keeping track. With tail f, I can keep track of what's going on with this out script. So I'm sort of watching what's going on here. So if I didn't like what was going on, I could go ahead and scancel. So if I want to scancel, I can just copy that job ID and then paste it, and then sq, and it's gone. Is that clear? I guess another thing.
Is there a way to cancel all? Oh.
Yeah, you can cancel all your jobs. I think it's like scancel u Madsen. You would never do that, right? Yeah, I would never ever submit a bunch of jobs and realize I messed up and have to cancel them. Oh wait, I used to do that all the time. Yeah, yeah. It looks like scancel u Madsen cancels all the jobs for me.
Cool.
So I don't know. I just love watchtail. Job 3577 out. I don't know. It's just like I like that. It's not completely filling up my screen, but it's I can keep an eye on what's going on. This is sort of like the scrolling version of what we just saw. Every 2 seconds, it's querying that file and running tail on it. Maybe it's nicer to we could do watch tail in 30. Now we get a little bit more. That's nice. Okay. So let's see. Oh, the other thing is saccount. So there's this thing called saccount, which I shouldn't give this fancy invocation first, but if I'm curious about how things have gone recently for me on the cluster, I can just use SAccount. And I think SAccount just by default says, like, what are the things that you did today? Here are all the different jobs that got run. Some of them failed, some of them were canceled, and one of them is still running. An SAccount is like super configurable. Like you can give it all sorts of rubbish. Like if you're curious about like how much memory did your job use, you can say how much RSS, which is like how much RAM did that process end up eating up, how many CPUs, yeah, max VM size, et cetera, et cetera. So it's a pretty powerful tool for figuring out how your cluster jobs have gone. And I don't remember, but there's some different flags about like, I don't just want today's, I want all the jobs that have been run in the past 3 days or something like that. You can get that too. Yeah, so it looks we've done everything. So hit parade, I'm not going to type it now because it'll show all sorts of people's names, but hit parade, if you're sort of curious, like, why is the cluster completely rammed full right now? You can type hit parade and it'll show you all the different people who have like tons of jobs running on the cluster and who are like the most heavy duty cluster users. No questions? Okay, well, I'll just sort of end with like my usual thing, which is that you can watch Star Wars in the cluster on ASCII with Telnet. Really? No real questions? I'm sure you can ask me about this.
I guess I have a question that's not so much about the resources, but how do you usually go about like deciding how many cores and nodes you're going to use for a particular job? Is that something you just kind of pick up on intuitively, or
that's a great
do you usually have a method?
That's a great question. So generally speaking, like it's better for the cluster to cut things into smaller jobs, which isn't exactly your question, but it's an important point. This is super distracting. So I will turn it off. But I don't know if I can. Anyway, it stopped. So that's sort of the first thing to say. I would also say that generally speaking, it's easier to get smaller machines. That's thing number 2. And thing number 3 is that there's Amdahl's law, which is, or I don't know if I'm not sure exactly if I'm invoking it correctly, but basically, even if you have a program that's multi-threaded, let's say you can thread it over 4 cores, it's not going, like, it's like running a single program over 4 cores is not going to be faster. It can never be faster than running that same program over 4 different CPUs. So if you have the choice of running 4 different processes, each of which are 4 cores, that's better than asking for a 16-core machine and running it on 16 cores. If you can split up your jobs into smaller chunks, then you win. On the other hand, some jobs are like, for instance, Zoran, you're training neural networks. I would just try out a couple different things. If you try running it on a 16-core machine and it provides a substantial speed up, and it seems like there's not too much of a wait for those 16-core machines, just go for it. Because it will be faster. I mean, TensorFlow is well engineered, or PyTorch, I guess, is what you're using now. So, does that answer your question?
Yeah, to an extent. I guess, like, yeah, from the little bit of background I kind of have on these things, I've always kind of learned to not use lots of nodes or computers when you're doing a lot of I/O stuff. But I guess with I didn't really think about it much from like just pure computation. So
Yeah.
yeah, that answers things.
I mean, I think they just like they're mostly for the cluster. They're interested in throughput, and like throughput's always better if you can split things up into smaller jobs. Yeah, I was telling Maggie that one time I basically brought down the mail server at Harvard because I realized that I could skip the queue by submitting like 3-second jobs, like millions of them. And it started emailing me about every single job. And that brought down the mail server. But I got my jobs done really fast. But I got lots of emails, lots of hate mails after that. So don't do that. Yeah, so Maggie also asked how many jobs is reasonable to submit on the cluster. And this is not something that I should probably go on the record saying, but definitely, like, don't think that you have to submit like 4 jobs. If you have 1,000 jobs, submit 1,000 jobs. It's okay. Like, the cluster can deal. I might get an angry email from Dirk later, but I think that's fine.
I learned yesterday that there is a limit of 10,000 or something.
Jobs. That's a lot of jobs.
Per user.
So you tried to submit 30?
Yeah.
You tried to submit your 30,000?
Oh, I asked permission over email, and they told me there was a limit. So.
Yeah, actually, yeah. So so there was a limit for Harvard as well. So what I did is I made a script that watched how many jobs I had submitted to the cluster, and then just kept on throwing them on. Once I had sort of, yeah. Anyway, why am I telling this? Don't do that.
No.
Cool. Well, that was fun. Hopefully it was clear. I think we covered all the bases. Can you think of anything I forgot? Okay. Well, happy clustering, everyone. And I'll talk to you soon.